For what we'll be doing next in this course, you'll need to understand the content of 4 different chapters on MATLAB. You don't need to understand all of the content on these chapters, and I also think that you may want to go through them in a slightly different order than the normal logical order going from 11 to 12 to 13 to 14. So this tutorial will give you an overview of the content of these 4 chapters and areas in which to focus on as you get ready for the homework assignment and the next class on MATLAB. So let's start with this diagram, which is actually first shows up in chapter 13, but it's a very good overview of what you should be trying to do as you create your MATLAB programs. In particular, we're going to be focusing on the first 3 lines which say think, sketch, and code. So how do you get from an idea of what you need to program to actual code that you can then work on and make sure that it's debugged? So you can see the different subcategories there. I'm going to break those down a little bit differently in the next slide. So think, sketch, and code. So what you're trying to do on the think side is to tell the story of what you want the code to do. And you could actually write this out as paragraphs and sentences if you wanted to. On the sketch part of this, there are 2 main ways to do this, and you'll probably end up using one or both, and you need to be familiar with both of them. One is called pseudocode, which is line by line describing what should be happening. And the other is a flowchart, which is a more visual approach that can show you the relationship of the steps that the program goes through. Both of those 2 will help you in order to generate code. And when you get to the point where you're generating the code, then it has to very strictly follow all the MATLAB syntax. And you can actually use pseudocode as the comments, and I will show that to you here in the next slides. So remember this flowchart, which we've looked at previously in class. And remember that we then created a program that went through the steps in that flowchart. The program that we generated also had comments in it. And if you look at this set of comments, they are basically describing each of the steps in the rectangles and parallelograms that we went through in order to have this program actually execute. So this shows you how you can very easily move from a flowchart to pseudocode. And in the case of this particular program, it was also very easy to move from the pseudocode to a flowchart as long as you knew all of the flowchart symbols. But what's also quite interesting is that if you have that pseudocode and you know the right way to write the syntax, you can very easily move to including the code, which is what you see here. Now notice that I didn't get rid or change any of the comment lines. All I did was filled in between the comment lines exactly what the program is doing, or the commands for the program. So this is what I would consider to be the absolutely best practice in terms of writing the first code that you're going to be writing if you're new to this kind of field. And it's also really good to have lots of comments in your programs anyway. So this is a very good example for you to think about and to use as you go forward. So let's remember what we did on the flowchart, and in chapter 12 it introduced the 4 flowchart symbols and the arrows that you see here. Now in class we have used 3 of those symbols, and what we're going to be concentrating on in this tutorial and the 4 chapters is the hardest of them, which is related to making decisions, and you need decisions in order to generate loops. So that's what the diamonds are for, and that's what we're going to be concentrating on next. So let's talk about those decisions and loops and how that works. So fundamentally what happens is the diamond allows us to branch the code, to do different things if the decision is that something is true versus something being false. And for true, you can also substitute the word yes, and true gets coded as a 1, and false gets coded as a 0, and false can also be thought of as no. So if you now look at the examples that are in chapter 12, those are very good examples to understand. So here is an example of pseudocode based on a description of what you might do if you were getting up in the morning. So I strongly encourage you to go through these sections of chapter 12 thoroughly and make sure that you understand them. That pseudocode can be understood by something like our rubber duck. So if you were to tell a rubber duck what you were going to do in the morning, you would probably describe it in this way, and you can see that the rubber duck could then walk through it. That pseudocode also again will relate to a flowchart, and here is the equivalent flowchart for the code that you see there. And this is also well described in chapter 12, and this is why I would encourage you to start with chapter 12 as you go through the different assigned chapters. And again, the rubber duck could step through this, and you could imagine the rubber duck floating through this particular flowchart, and on the various different branching depending upon what the circumstances are. And that's a good way to think about this, and these two again directly relate to each other. Okay, so let's go back to this decision box, this diamond, and once you now understand those concepts in chapter 12, that's when I recommend you go in and read chapter 11, because chapter 11 describes how the logic works for those decisions. So in there in particular, it talks about the relational operators that you're going to use, and you can see that there's a double equals, there's a tilde with an equals, there's a greater than or equal to, a less than, and a less than or equal to. And those you should learn and understand and memorize. In addition, in chapter 11, there are two other tables that I would encourage you to be aware of and to understand how they relate to working with these operators. One of those tables combines the order of precedence information for doing calculations like the power, multiplication, division, addition, and subtraction, the parentheses for grouping things, which is always at the highest level, as well as a colon operator, which we don't use all that frequently. And then below that are the relational operators and the logical operators and or. And as you notice that the logical negation is actually in a different place, all of that is explained in chapter 11 as well. And in particular, there's a separate table that goes through in greater detail what those three logical operators actually mean also. So it's important to understand those. You will encounter them, and you will want to know how we can combine these. And I'll have some homework questions that relate to your understanding of working out whether a particular logical sequence is true or false, and therefore how it affects the decision boxes that we would be working with, which are the things that you saw in chapter 12. Okay, now that we have covered an overview of chapters 11 and 12, or actually I should say 12 first and then 11 next, in chapter 13 we're going to be talking about if statements. So if kinds of decisions, and there are two of those that you want to be aware of. The simplest is if, else, end. And there's several examples in that chapter. They are good examples, and they are worth really understanding in detail. One of them is a flowchart and sample program for working out how much somebody should get paid depending upon how many hours they work and whether overtime is involved or not. So I encourage you to understand that one. There is the flowchart, and the flowchart in that case includes the pseudocode, and here's the related MATLAB code. So I really want to make sure that you understand that one very completely, because it is something that is very closely related to the kind of code that we will be working with. There's a slightly more branchy version, if you will, which is that you can use an if, and then you can have a branch off of that, which is an else if, and then you can have else's, and you finally get to the end of that. And there's There's a good example of that also, and it has to do with grades turning from numbers into letters. I would encourage you to understand that flowchart and to understand how the related code works as well. So those are all related to if statements. That's in chapter 13. You'll want to be familiar with how that works. Then in chapter 14, you have for loops. And we will be starting to use for loops because we're going to need that in our example for the next program that we run. So it is worth understanding this diagram, figure 14.4, and the sections that come before and after that to explain how a for loop works and how it is similar to having an if statement in there, but it does a series of steps automatically based on the way in which you code it. So finally, what I would like to share with you, and this is not in the chapters, but these are very good examples of how an if-else end type of a conditional would look if you have a flowchart for it, and then the sample code that would actually work for that exact flowchart that you see above. And I've done the same for a for and end loop so that you can actually code that, understand how it works, and see how the related flowchart looks as well. Those two, plus the other information that is in those chapters and in this tutorial on the if statements and the for loops, are things that you should definitely know and understand. Now, when you do these two examples, I should note that they're using several functions that we haven't covered before. They're pretty straightforward, but you want to be aware of them. One is the input function, which stores a value into a variable and allows you from the command window to put in a number, which is what you're seeing here on the lower left, where you put in a temperature of 32 and it will generate the word uncover tomatoes. If you put in a temperature of 31, it will generate a result of cover tomatoes. You may want to write that code and play with it. That also uses the display command, and that's at the end. That's the output. And so you can see that also, that it generates that. And I didn't actually put that display, and I didn't actually put the input into the flowcharts that you see above, but you can basically work out how that would work. And then in the example to the right, you'll see that I also have a function called number to string, or num to string, which converts numeric information into string information. And that one also uses a display function. In that particular case, I did show you the display function. Notice that I have an error there. I should have made that display into a parallelogram rather than a diamond. I'll do that the next time I update this particular tutorial. And then notice also that if I have a variable that is a string, so it's not a number, but it's letters or characters that I want to use as letters or characters, then I'm going to put those into single quotes. So that's everything. So that's everything I wanted to cover in this tutorial. And again, my recommendations are that you read through chapter 12 first, then read chapter 11, and I think it will make more sense. Then you can move to chapter 13, which is where we get into if statements, and then finally do chapter 14. And I think all of these will help you a lot to understand what you need to do for the homework and to be prepared for class on Monday.